going to continue with A16, Part 2, inverse functions, and I want to go over a couple of tidbits on the definitions, just pretty basic. So when we have f and g are functions, and if they're going to be inverses, this has to meet the criteria. F of g of x, so the composite, is equal to x, so out comes an x, and g of f of x is a composite where it also comes out to equal to x, and we'll show an algebraic example of that later on. The domain of f is going to be the range of the inverse. The range of f is going to be the domain of the inverse. This leads us to the concept of one-to-one functions. For every element of the domain, there's a unique range, and again, for each range, there's a unique domain. Neither the x's or y's repeat. Another little tidbit is that the inverse will always be a reflection of the function f over the line y is equal to x. So here we have a table, and we're going to check to see if it's an inverse or not. Well, real quick, and we can take a look at our x's. They definitely don't repeat, but our y's do. They repeat here and here. So this fails to meet the criteria of an inverse function. If this was 12, we'd have unique relationships going both ways, a one-to-one, and we would have met it. Another one to look at is if we were given a graph, and this doesn't happen a whole lot, and let's just take a look at the quadratic real quick. Okay, so what I have here is if x was -2, y would be 4, and if x was 2, y would be 4, and in a graph we would see that and it would fail. Well, we call this the horizontal line test. If I were to draw a horizontal line and it met here and here twice or more than twice, it failed. But we're going to spend most of our time algebraically. So I'm going to ask you questions like this. Find the inverse function. And I give you f of x as something. So that's just nothing more than y is equal to 2x minus 3. Now you're going to have to excuse my writing tablet. My daughter's dog knocked it over and the pressure plate is kind of funky. So I'll probably have to get a new one. What we're going to do first step is we're going to have to swap the x and the y. And let's go ahead and solve for y once we do that. See, there it goes. It's acting up. Y minus 3. I'm going to add 3 to both sides. Come on. And I'm going to divide. So I have y is equal to x plus 3 over 2. Last step, let's go ahead and write it in our proper notation. And this is actually an extra step because we should have done that right here. We could have done y next. You could also done y is equal to, f of x is equal to that, and replaced it. Let's look at one where we have to substitute more than 1x. And you just got to watch out for your algebra, that's all. So you're going to have x plus 1 and x minus 2. And we're going to go ahead and substitute. Like I said, I have a very bad writing thing now. And I'm going to have x is equal to y plus 1 over y minus 2. And I'm going to solve for y. Well, the first thing I'm going to do is I'm going to cross multiply. So I'm going to do the symmetric again. Y plus 1 is equal to x times y minus 2. And, oh gosh, this is driving me nuts. And I'm going to go ahead and distribute. So y plus 1 is equal to xy minus 2x. And I might as well go ahead and get rid of that 1 minus 2x minus 1. And I'm going to get this y to the other side. I'm going to do y minus xy is equal to negative 2x minus 1. So I'm going to factor out the y, and I have 1 minus x is equal to negative 2x minus 1. Then divide out. Y is equal to, sorry about this, negative 2x minus 1 over 1 minus x. And of course, I need to go ahead, I'll just put it right here. There we go. Okay. That's y to the negative 1. So the inverse is equal to negative 2x minus 1 and 1 minus x. Let's see how this writing tablet does on this example. This could be fun, but at least I'm going to get you partway through it. Let's see if I can even finish this example with this thing. So first thing we're going to do is we're going to prove that these are inverses, so we have to do this is equal to x. So I'm going to take f of x, so I'm going to substitute in 2/3, big old parentheses here, plus 2. And this simply goes in right here. Okay, that's going to be 3/2 x minus 2. So all I'm going to do now is, I guess I'm going to go ahead and distribute that 2/3. And now distribute the 3/2 first. Okay, so I'm going to have 2/3. Okay, I'm going to have 3/2 x, and that's going to be 1. So that's just going to be minus 3. Okay, and I have a plus 2 over here. Now I distribute the 2/3, and that's just going to be an x, and 3 divided by 3 is 1. So I'm going to have minus 2 plus 2 is equal to x. That one fulfilled it. Now let's go ahead and do the next one. I'll do this one in green. I'm going to do g of f of x. All right? So I'm going to go ahead and write this. This is a fairly good technique. I'm going to write this down, and I'm going to put in big parentheses where that function is going to go. Okay? And I'm going to have minus 2, and I'm going to close the parentheses, because this right here is going to go here. Okay? It's going to go right there. So I'm going to have 3/2, and I'm going to have a couple of big parentheses here, 2/3 x plus 2, and oops, I didn't mean to do that, minus 2. There should be a minus 2 right there, minus 2. Okay, and my writing pad is dying on me, but I'm not going to redo this video. So when I distribute, I'm going to, actually I'm just going to cancel out this plus 2 and minus 2. So I'm going to have 3/2 times 2/3 x, because these cancel out, boom and boom. And that's going to equal 2x. All right? So I proved here and here that these are inverses of each other. All righty? So I'm going to go ahead and get this one loaded and order a new writing pad, which will be in probably a few days. Okay, see you next time.